Hey, welcome! So today we're going to unpack a really fascinating compound that, honestly, you've probably come across without even realizing it. It's called beta-glucan. It's this natural fiber that's in your morning oatmeal, the mushrooms you cook with, and even in some super high-tech skincare products. Now, it gets a ton of praise for its health benefits, but that brings up a really important question we're going to dive into today. So, what in the world is beta-glucan? Well, at its heart, it's a polysaccharide, and that's just a scientific way of saying it's a long chain of sugar molecules, specifically glucose. But hold on, don't let the word sugar throw you off. Because of the way these glucose molecules are all linked up, our bodies can't really digest them. Instead, they act like a soluble fiber, just passing through our system and, well, interacting with it in some pretty cool ways. And that right there brings us to the core of this whole explainer. I mean, this stuff is everywhere, from the food we eat to our bathroom cabinets. So the big question is, with all this exposure, from the outside of our bodies to the inside, is it actually safe? To figure that out, we're going to take a journey from the outside of the body in. We'll kick things off with how it affects our skin, then we'll see what happens when we eat it, and finally, we'll tackle the most serious scenario. What if it gets directly into our bloodstream? We'll also unpack what it means that it's an immune modulator before we get to our final verdict. Okay, first up, safety on our skin. You know, beta-glucan is getting super popular in cosmetics for being really moisturizing and calming. So for most of us, this is our #1 point of contact. Let's see what the science has to say. The evidence here is pretty direct, which is great. One of the key studies took a look at a special modified beta-glucan that comes from yeast. You know, the exact kind of thing you'd find in a high-end face serum. They tested it directly on human volunteers, and the results? Totally clear. It wasn't an irritant, and it wasn't a sensitizer. That's a fantastic start to its safety report card. All right, let's move inward. What about when we eat it? I mean, we get beta-glucans all the time from foods like barley and oats, but what happens when you concentrate it and study it like a supplement? So let's start with barley. In this 28-day study, they fed Worcester rats a diet that was packed with beta-glucan from barley. The scientists watched everything, their growth, their organ health, their blood, and you know what they found? Absolutely no negative effects that had anything to do with the beta-glucan. And to really put that into perspective, the highest dose these rats were getting was 5.6 grams for every kilogram of body weight every day. For a person, that would be like eating over 300 grams a day. That's more than 100 times the amount that's recommended for helping with cholesterol. It just goes to show you there's a huge safety margin here. And the evidence just keeps piling up when we look at a different source, this time baker's yeast. This was a longer, 91-day study in rats, and guess what? It tells the exact same story. Even over 3 months, giving them yeast-derived beta-glucan every day showed 0 adverse or toxic effects. The same study also wanted to see what would happen with a single massive dose. They were looking for something called the LD50, which is a measure of a lethal dose. They found it was more than 2,000 milligrams per kilogram. In the world of toxicology, that's a clear signal that a substance has very, very low acute toxicity. And this is where it gets really interesting because you see this amazing consistency across all these different sources. So now let's look at mushrooms. In a 90-day study with rats, this time using beta-glucan from the lion's mane mushroom, again, no significant negative effects. Barley, yeast, mushroom, the pattern is crystal clear. It really hammers home this idea that because beta-glucan is basically a fiber that our body doesn't absorb, it's just incredibly well tolerated when we eat it. In fact, the no observed adverse effect level, or NOAEL, for this mushroom beta-glucan was set at 2,000 milligrams per kilogram per day. And you know why? Simply because that was the highest dose they even bothered to test. They couldn't find a dose high enough to cause a problem. Okay, let's step it up. Now for the most serious situation. What happens if beta-glucan gets directly into our blood? This could happen in a couple of ways, either as a tiny, accidental contaminant in something like a medication, or on purpose as a high-dose IV treatment. Wow, just look at the sheer scale of difference here. It's wild. The maximum amount you might get from contamination is maybe 500 nanograms. Now, compare that to a therapeutic dose they've actually used in clinical trials, which can be 280 times million nanograms. That means the contaminant level is just a tiny speck. We're talking over 500,000 times smaller than doses that have been safely given to people as a therapy. And we've got animal data to back up the safety of using it intravenously. A study using a mushroom-derived beta-glucan called lentinan specifically checked for organ health after a single IV dose in rats. And the findings? No damage, not to the heart, liver, spleen, lung, or kidneys. So far, the safety record looks rock solid, but this brings us to a really important detail. Safe doesn't mean inactive. We know for a fact that beta-glucan interacts with our immune system. So the question is that interaction safe? So to get a handle on this, scientists use this term IMI. It stands for innate immunity modulating impurity. It's basically a category for molecules that can talk to and switch on our body's first line of immune defense. And beta-glucan is a well-known IMI. But here's where context is absolutely everything. Let's compare beta-glucan to another famous IMI, endotoxin, which comes from bacteria. Now, endotoxin is incredibly powerful. It can trigger a huge immune response at minuscule concentrations. We're talking picograms per milliliter. Beta-glucan, on the other hand, is a completely different ballgame. It is far, far less potent. You need thousands of times more of it, up in the microgram range, to get a similar response. It's more of a modulator, not a shock to the system. All right, we've looked at the evidence from the skin to our diet, all the way to the bloodstream. It's time to pull it all together and give the final verdict on the safety of beta-glucan. So, what's the big takeaway? We've seen that from the outside in, the story is incredibly consistent. On our skin, human data says it's good to go. When we eat it, tons of animal studies from barley, yeast, or mushrooms all say the same thing. No toxicity, even at really high doses. And in the most extreme case, directly in the bloodstream, there is a massive safety margin. The verdict from all this evidence is clear. Beta-glucan has a very, very strong safety profile. And this quote from one of those key studies just nails why it's so safe when we eat it. The researchers basically say its great safety profile makes perfect sense because, well, it's a fiber. It's indigestible and it doesn't really get absorbed into the body. It just does its thing in the digestive tract. So I think we can say with a lot of confidence that beta-glucan has a really robust safety record. And that shifts the whole conversation, doesn't it? It's not about is it safe anymore, it's about something way more exciting. Given that it's so safe and we know it has beneficial interactions with our bodies, what's the next frontier for this amazing superfiber? What's its true potential?